All right, another inference test here. So let's read through this problem first, and we're going to try to decide what type of inference test we should be performing. The two questions we're going to keep in mind is, are we creating a confidence interval or testing a hypothesis? And do we have one sample or two samples? So let's read through that with those two questions in mind here. Jaime is a market researcher interested in nutrition. He suspected that people in the 20 to 29 age group were more likely to say they were a vegetarian than people in the 30 to 39 age group. He obtained separate random samples of people from each age group. Here are the results in this table. He wants to construct a 99% confidence interval. 99% confidence interval to estimate the difference between the proportion of people in each group who say they are vegetarian. So it says confidence interval, so we're going to be in the creating a confidence interval side of our flowchart. Then we need to decide, is it one sample or two samples? So it says here, there's a couple of things that'll clue us in. One, it says he obtained separate random samples, so we know there's more than one here. And our two random samples come from each of these different age groups. So these two columns in our table, one's 20 to 29, one's 30 to 39, these are going to be our two samples. So we are creating a confidence interval for two samples, and we are working with proportions. There will be no means on this test, only proportions. So we know we can go right to proportions. And it is a two proportion Z interval, a two proportion confidence interval. Another way we can know that it's proportions is because it says between the proportions. So even if it wasn't for this test, you could still identify it as this test because you know it's proportions. That's what we're comparing here. So let's actually perform the test. You can find the template for this in your study guide. Let me find what it's labeled in the study guide, and I'll write it at the top here so y'all can find it easily. Doing a confidence interval for two proportions. If you go in the study guide, you will see a template labeled with that. Confidence interval for two proportions. And we're going to go through doing that template, filling it out together. This is what you would do if you were asked to perform this question on an FRQ. You would go through these four parts that we're about to do. You can also find the template for this in the Desmos link from the review. So if you'd want to fill it out there along with me, you absolutely can, or you can do it on your own paper. Feel free to pause this video at any point if you want to try a part of it on your own first. So box 1 is going to be naming our critical values and naming the test. So the test for this one we just found on that flowchart was a 2-prop Z int, 2 proportion Z interval, confidence interval really. We call it Z because it's using the Z star value to calculate that confidence interval. Then we need to find our P1 hat and our P2 hat and give some proportion on what each of those is. So the 1 and the 2 is denoting which sample we're talking about. So let's look in the problem and decide which one we want to denote as sample 1 and which one we're going to call sample 2. I'm just going to go in the order they're listed on the table here. So I'm going to call sample 1 all of my 20 to 29-year-old people. I'm going to call sample 2 all of my 30 to 39-year-old people. So my P hat, is the proportion of success in that sample. So if I look at sample 1 here, 20 to 29-year-olds, and I look how many of them responded positively that they are a vegetarian, that'll be by number of success. There were 12 that said they are a vegetarian. So that's our number of successes. And we're going to divide that by the sample size for sample 1. There were 80 people total in sample 1. So your P hat is always calculated by doing the number of successes over the sample size. And the 1 just tells us that we're talking about specifically sample 1 for this problem. Because there are two samples, we need to differentiate them like that. So 12 over 80 is going to give us our proportion of success for sample 1. If I put that in my calculator, that comes out to be 0.15. And I will give the AP graders a little bit of context on what that is, that 0.15. What's it describing? It's the proportion of vegetarians in the 20 to 29 age group. I'll do the same thing for P2. So now I'm looking at the 30 to 39 age group. How many of them said yes to being a vegetarian? Again, 12 of them did. So 12 will be on the top, and on the bottom in my denominator, I will divide by that sample size. So how many people total responded from that age group? If I look in that total row, 120 of them responded from the 30 to 39 age group. So 12 over 120 is going to give me my proportion of success, my P2 hat for sample 2. And 0.1 is going to be what that comes out to be. Again, I will give some context on what that 0.1 actually is. It's the proportion of vegetarians in the 30 to 39 age group. And that is everything that we are going to put into box 1. Box 2, we're going to check the conditions. Because we have 2 different samples here, we have to check the conditions for each of our samples using the same template each time. So number 1, the random sampling condition, we will look in the problem and see that it states random sampling is occurring. So if we look at right here, he obtained separate random samples. The fact that it tells us that directly means that for sample 1 and for sample 2, the random sample condition is satisfied. So I'm just going to simultaneously check the conditions for both of those samples here, just to save me some time. So for sample 1 and sample 2, random condition is satisfied for each one, because that sentence said that they were both sampled randomly. Random condition is given. Random condition is given. Then we need to satisfy number 2, the 10% condition. We're going to use that template that you see, that sentence with the fill in the blanks. So we're going to say it is reasonable to assume that we fill in this first blank with what our sample size is. So for sample 1, our sample size was 80. So I'm going to say 80 is less than 10% of the population of, and here we'll describe what that population would be. For sample 1, it was the 20 to 29-year-old people. So 20 to 29-year-olds. We filled in that first blank with the sample. The goal of this second condition is to say that our sample size is less than 10% of the population size. So we said for our first blank, our sample size is 80. Our second blank, we describe the population. Do the same thing for sample 2, but now we are talking about sample 2. So it is reasonable to assume, again, that our sample size for sample 2, that was 120, is less than 10% of the population of 30 to 39-year-olds. That's our sample 2. That's the population we sampled them from. And there's one more sentence we need to tack onto this, or one more little part of a sentence. We actually filled in the blanks already. We know those are good. And then we just have to say, therefore, independence can be assumed. And therefore, independence can be assumed. Conditions 1 and 2 for both of my samples have been checked. Condition 3 is going to be the large counts condition. I need to check and make sure that my n times p1 hat is greater than or equal to 10, n1, sorry, and that my n2, my n1 times 1 minus p1 hat has to be greater than or equal to 10 as well. So you'll notice, since I'm in sample 1, all of my subscripts here are 1. I'm talking about my n1 times my p1 hat and my n1 times 1 minus p1 hat. And then I'm going to do the same thing down here, but now I'm going to be in sample 2. So it's going to be n2 times p2 hat has to be greater than or equal to 10, and n2 times 1 minus p2 hat also has to be greater than or equal to 10. If I check both of those, then this condition will be satisfied. I'm going to check them. I'm going to use the bottom part of this box to check this one because I'm going to run out of room here. So my N for sample 1, my N1 was 80. And my P1 hat we calculated in the first part was 0.15. I plug them into these formulas here. So N1 times P1 hat is going to be 80 times 0.15. We want to make sure that's greater than or equal to 10. Put that in your calculator. You get 12, and that is indeed greater than or equal to 10. And then we're going to check that N1 times 1 minus P hat, so 80 times 1 minus 0.15, has to also be greater than or equal to 10. Plug that in your calculator, check it out, see if it checks out. 68 is also greater than or equal to 10. So that one, this is good for both. We need both of them to be satisfied, not just one. They both do. If they are both satisfied, we will say, therefore, the large counts condition is satisfied. And that is sample 1 done. All 3 conditions checked. For sample 2, we're going to do the same thing. Our N2 was 120. Our P2 hat was 0.1. I'm going to plug into both of these same way I just did over here. Feel free to pause this at any point if you want to try it on your own first and then check with mine. So N2 times P2 hat is going to be 120 times 0.1. I want that to be greater than or equal to 10. That's going to come out to 12. That one's good. N2, again, that's 120 times 1 minus that P2 hat. Put that in your calculator. Comes out to 108, and that is also greater than or equal to 10. So that's good, and then we can say, therefore, the large counts condition is satisfied. Amazing. Calculator talk is next. We are going to do a 2-prop z int, as we already decided earlier. Your calculator is going to ask you for some values, and you're not just going to put them in the calculator, but you are going to tell the AP graders on your paper what numbers you put into the calculator. So for this one, let me get up my template here. It's going to ask you for x1, n1, x2, n2, and confidence level, which it calls C level. These are the things that your AP grader wants to know to be able to give you the points. Your X1 and N1 are actually going to be the same thing that you use to calculate that P1 hat. X1 is the number of successes, N1 is the sample size. So here we have 12 and 80. X2 is my number of successes for sample 2, that was 12. And 2, my sample size for 2 is 120. And the confidence level, I'm going to go back to the problem and see what % confidence level they wanted me to be at. I want to be at a 99% confidence level. It's a 99% confidence interval. So my C level will be 0.99, just writing that 99% as a decimal. I'll put that in my calculator. Go to stat, test, down to all the way down to A. Oh, sorry, B. All the way down to B. A 2-prop Z int, right? It should match those. 2-prop Z int, matching. You can see all this information we already wrote down on the paper, so now we're just going to enter it in. 12, 80, 12, 120, 0.99 for our confidence level. We're going to calculate, it's going to give us a confidence interval. That confidence interval is from negative 0.078, if we round it, to 0.175. So this is everything that you will write in box 3. You'll also notice that it calculates your P1 hat and your P2 hat for you. They match what we did by hand earlier. If you would like to start with box 3, have it calculate these, and then put that into box 1 and do the conditions next, you can do that. It's up to you, the way that you do it. The order to me does not matter. So if you want to have the calculator calculate these, feel free to skip to box 3 first and then backtrack. This is all the information we'll need to put in box 3, and box 4 will be interpreting that confidence interval. You will use the template that is on the paper that's in the study guide. We are blank % confident. I'm going to fill in that blank with the confidence level that the problem told me I should be at. We are 99% confident that the true difference, you'll notice this is the main difference between a 1 proportion confidence interval and a 2 proportion, is we're no longer saying we're confident where the true proportion is. We're looking at a difference in proportions because we have 2 of them now. So instead of saying the true proportion, we are saying the true difference in proportions of, and then we'll describe the context here. So we were looking at vegetarians in the 20 to 29 age group and vegetarians in the 30 to 39 age group. Those were the 2 people that were the 2 samples that we were comparing. We described that population, and then finally we're going to fill in those last 2 blanks is between with our confidence interval from the last part. So I'm going to go back up to box 3, steal those numbers from my confidence interval, negative 0.078, 0.078, and 0.175. And that is all 4 parts for constructing a confidence interval for 2 proportions. Here's box 1. Check your answers if you did it on your own. Box 2, box 3, and 4.